So I want to go through proofwriting and assign you some homework. We do have a quiz scheduled for Monday. Some of you said that one of the turnoffs from undergrad was writing proofs, that you don't feel like you were comfortable with it. Almost everybody feels that way when they get out of undergrad program. It doesn't matter what undergrad program they got out. They might lie and say that, oh, I just was really great at doing proofs. But it's their first introduction to proof. So this is the second time. At least it's not the first time. So just a little consolation. There's several steps. So when I went to grad school, I was a typical American student where I was trained in an American institution. And I went to an institution which was Georgia Tech. It was not a shabby place. But a lot of the students came from overseas, and some of them even had PhDs in their own country in a different, someone was an electrical engineering PhD, someone was a math PhD from Venezuela. So they were really strong people that came there. And they all seemed to know how to write a proof. So I felt like an idiot sitting next to them, until one German girl took me under her wing and said, let's see if we can do the impossible and teach Di to shut her mouth and actually learn for 5 minutes, to think for 5 minutes. And what she helped me do is just algorithmize the process involved in writing a proof. And once, it took me a semester to just be quiet and stop asking questions and realize that I just need to think. Once she taught me that, I thought, why doesn't everybody teach it this way? And then there wouldn't have been this disconnect in the first place. So this is my attempt to take what she taught me and relay it back. The first step in writing a proof is to take down all the information you know. Those are your puzzle pieces. I call them nuggets. You might not use all of them. In these beginning proofs, you don't use all of them, but that's that first structural thing you want to do. You want to take all the words between the if-then statement, between the if and the then, and splice it out. So for example, if I want to prove if G with the binary operation star is a group, then the identity element is unique. So that's the statement I want to prove. What I want to splice out as my no is all the words between the if and the then. So that's my no. So what do I know? I know G is a group. The second step is to expand that no as much as I can so it's something I can get my hands on and move around. So what do I know about G being a group? Well, write down all you know about it. G being a group means it has an identity. G being a group means it has inverses. G being a group means it's associative. So I just list them out. It's like you're trying to put a puzzle together, and people don't understand that this is a huge step, because if you don't have the puzzle pieces sitting there, you know them. Of course you know them. But if you don't have them sitting in front of you, you can't see them. It's like saying, okay, there's puzzle pieces. I'm trying to put a 1,000-piece puzzle together. But half of my puzzle pieces are in the living room and the other half is in the kitchen, and I'm going to put the puzzle together in my bedroom. Why would you do that? Put all the puzzle pieces together in front of you and start mapping them out. So that's what you're trying to do. Write down again what you have to show. Those are the words past the word then. So after then, it says the identity element is unique. So what I have to show is I have to show that the identity element is unique. So this is the first 3 steps of just writing out a proof. The 4th step is to take what you have to show and write down what that means, flesh out what that means. So expand the show. That's kind of where you set up a plan. You're trying to figure out what it is you're trying to arrive at. So for some kind of problems, like after I chose this one, I thought this was a bad one, because this one has standard operating procedures. Anybody in industry knows what SOPs are. This one has, whenever you show something's unique, you assume there's 2 and you show they're equal. That's the standard operating procedure for uniqueness. So assume there's 2, E1's an identity and E2 is also an identity, and write down what that means, expand it out. My goal, my end goal, is to show that E1 is equal to E2. So I really map that out and flush it out and make sure I have it all in front of me. Now, this sounds so silly when I show it to students, because they're like, well, you know, duh. But it took me a while to get to this point, because I think in our American system, we're trained that smartness is equal to fastness. You know, all the way through my undergraduate career, it was the student who got the answer the first who was the winner, not the student who thought for a long time. So let me think about that. I think I need a cup of coffee and I need to go home. I can give you the answer tomorrow. You were not rewarded for doing that. You had to get the answer right and you had to get it fast. So by the time I came to grad school, I had this idea in my head that somehow I have to go all the way to step 4 and bypass step 1 through 3. And that's what held me back. So what all my German friend was trying to do was slow me down. That's what she meant by think for 5 minutes. She wanted me to start breaking things down and slow down. And what it did for me is, because I was trying to go straight to step 4 and write my game plan and write out the proof, I would be staring at the problem for a long time. I felt that was part of my studying. I'm staring at it. I am thinking. But I was doing the puzzle piece thing. Some of it was in the kitchen, some of it was in the living room, and I was trying to put the puzzle piece up together in my bedroom. And it wasn't working. So I think that was the huge issue, and that held me back. So this also pops in my no, by the way, because as soon as I write assume is part of the hypothesis. So that goes up to the no category as well. So I have my whole list of puzzle pieces. These are my nuggets of information that I'm allowed to use. I'm allowed to use all of this. The show part I'm not allowed to touch. That's going to be my last line before my little smiley face at the end. And I write my goal. So I've now got it all straightened out in my mind. So now I'm going to assemble the proof. So I was on step 5. I would bypass everything else and try to go straight to step 5. And staring. I could Superman with laser power eyes, stare at the problem for a long time, and it will just shh. It didn't work. So E1 star E2 is E2 because E2 is identity. But E1 star E2 is also E1 by property of identity, right? That's what identities do. They leave things unchanged. But then I'm done because those two things were equal to the same thing. So this one I didn't need all that list of no's. So I told you it's a kind of a bad example, but that's the procedure for writing a proof. One of the great things about finally stepping back and doing this is I stopped staring at the problem. I was actually doing something. I think this is a standard feeling people get when they are, at least in the American system. It seems like the Germans they were born just writing proofs or something. I don't know. But for us American students, we were all in the same boats. We all felt the same way. Staring at the problem felt like we were wasting time. And so you didn't feel like you're studying for 2 hours. You felt like you were wasting time for 2 hours. You didn't get anywhere. So at least as I was writing out these steps, I felt like I was doing something. So it was something more productive than staring at the problem. It was just a deeply frustrating experience, I remember. I think my undergraduate times, I tried to avoid proofs. My graduate times, I couldn't avoid proofs because that's what mathematics is. Mathematics is about writing proofs. So the first year, I think I just tried to complain a lot because it's American. It's going to complain a lot. So I complained a lot. I said, I can't believe they're going to ask proofs on the test that I haven't seen before. Can you believe he's going to ask us something we haven't seen before? And I did a lot of those kind of things in the classroom. I was only 21. But yeah, this helped a lot.
Are we going to have this at the end of the class?
Yes.
Is there, can I see the list again of the questions?
What time are we at? Yes, I'll give you a list of the questions. Yeah, I'll let out class so that you can see the questions.
Oh.
So here's the homework that I'm assigning. I actually posted the PowerPoints already. The PowerPoint's already posted online. I'm going to try to post them always before class so that you get a copy of them. And some of the sample problems, not these ones I assigned, but like I think I did 30 and I did 32. So I did some problems around it so that you can see the structure of how to do it. And if you need me to, I will go in and make a little video of one of those that you actually want to see words around it, see it being explained. I can do that too.
34 or 39?
Is that what I did? 34, that's 34. So I think I did 30, this is at page 48 and 49. So I did 32 and I think I did 30. Yeah, I did it in a lot of detail so that you could see how I don't just show you the proofs, I show you how I got to the proof. So I do like how I got there, what I was thinking every step of the way, and then I develop a clean version of the proof. So it's not like you're going to get a show of the clean version of the proof. You're going to get how I did all those steps in between.